Okay, let's talk about the unit hydrograph. Remember, the goal is to predict the event hydrograph from a precipitation event. So some precipitation falls on a watershed, and we want to look at the response in the discharge of the stream that's draining the watershed at its outlet. The idea was that we extracted the excess precipitation from the hydrograph to create a hydrograph of effective precipitation. That's this thing over here on the left. That's the effective precipitation hydrograph. If we take the area under that effective precipitation hydrograph, this area here, right, that's equal to the total depth of effective precipitation that runs over the land and eventually enters into the river. On the other side, we extracted the event discharge from the hydrograph to create the event hydrograph. That's the hydrograph shown here on the right. If we took the area under the event hydrograph, we got the total volume of quick flow water that entered the stream. However, if we want to compare apples with apples, we can divide the event flow discharge, Q, up here, Q star, in terms of volume per time, over here, by the area of the watershed, and we get event flow discharge in terms of length per time, in other words, a depth. So if we do that and we plot the event flow discharge in terms of length per time, then these are directly comparable. They're both the area under here and the area under the hydrograph both corresponds to the depth of water that originally fell on the watershed and eventually ended up in the stream. And remember that what we're saying is that if by definition, this amount of water here in the effective precipitation hydrograph has to be exactly equal to the amount of water here in the event hydrograph. We also know that the shape of the hydrograph is important and can be described as variables as such as the lag time, here, this time here, the lag time, or the total base time, the length of time of the event hydrograph, or the peak height, the height of the peak of the event hydrograph. Those are all used to describe the shape of the hydrograph, which varies from watershed to watershed. Now, if we think about it, the shape of the hydrograph ought to depend on the specifics of the watershed, right? Its size, the geometry of the watershed, its slopes, its soils, its vegetation, the degree of urbanization, anything else that affects the way in which water flows from the land into the river. Since these things stay relatively constant, the only thing that will change between precipitation events is the nature of the hydrograph itself. In other words, the volume of water and the timing of when it falls. The unit hydrograph idea is this. Create an event hydrograph for a specific watershed that results from a simple precipitation event that releases 1 unit of excess water on the watershed. In other words, we're going to say in this event, in this situation, that this volume or this depth of water is equal to 1 unit, whatever that means. And therefore, this amount of water is going to be, that's the area under the event hydrograph, is going to be equal to 1 unit by definition, right? So this gives us the response of the stream to 1 unit of excess precipitation distributed over the watershed. And since the watershed properties remain the same, we should be able to scale this unit hydrograph up or down, or add a sequence of them together to produce event hydrographs from any precipitation event, no matter how long or complicated or how much water it produces. So let me give you some examples of how this works. Suppose this hydrograph on the bottom is the unit hydrograph that results from a 3-hour precipitation event. So the up here in blue is shown the hydrograph, and since we're talking about a unit hydrograph, well, we said 3 hours. So this time interval here is 3 hours, and we're saying that the depth of water underneath this is 1 unit, and since we're dealing with the metric system, let's call this 1 centimeter of water. So in other words, the precipitation rate here has to have been 1/3 of a centimeter per hour. Maybe you can read that. 1/3 of a centimeter per hour for 3 hours results in a total excess precipitation of 1 centimeter. And that 1 centimeter is going to therefore also represent the area, the area underneath the unit hydrograph, which is shown below in green. So that's what this is. That's what this hydrograph, this unit hydrograph represents. It represents the response of the stream to an input on the watershed of 1 unit, in this case 1 centimeter of excess precipitation falling over that occurred during a specified time unit, in this case 3 hours. Now let's see what it means to say that the unit hydrograph is scalable. What happens if instead of 1 centimeter, 2 centimeters of excess precipitation were to fall on the watershed? So now we're going to drop 2 centimeters, and so I can just double this, right? This is going to be twice as high. So in the same 3-hour period now, we're going to have a total excess precipitation now of 2 centimeters total. So each one of these is 1 centimeter, and the sum is 2 centimeters. So what will the resulting stream event hydrograph look like? Well, since it's scalable, what the event hydrograph is going to look like, it's just going to be double every value here. So what I'm trying to do is just show the result. So this curve represents doubling the discharge value at every point. And this then will be the hydrograph that results from an excess precipitation of 2 centimeters over 3 hours. So we just simply doubled the hydrograph. Every discharge, we doubled it to get the discharge that represents a 2 centimeter, 2 units of excess precipitation. To demonstrate what I mean by additive, let's think of a different thing. Let's suppose now that we have a rainfall event that starts like this, with 2 centimeters of rainfall, or excess precipitation, sorry, in the first 3 hours. And then in the second 3 hours, we just generate 1 centimeter. So we have a much more complicated event here, right? We start off with a stronger rain that falls, and we get 2 centimeters of excess precipitation. And then in the next 3 hours, remember this is another 3-hour increment, another centimeter of excess precipitation is produced. So what's the hydrograph going to look like now? Well, we have already the hydrograph that results from the first part of this, right? From the part that happened in the first 3 hours. That was just the sum, adding up the 2 unit hydrographs on top of each other to produce this. Let me give you a different color here. So let's call that curve here in red. So this red curve here now is the hydrograph, the event hydrograph. That's the result of doubling the unit hydrograph because we have double the amount of precipitation. So that's the one. Maybe I'll try to make it really clear. This is it in red now. Okay, there it is, and that's 2 centimeters. So now we want to figure out what's the hydrograph going to look like if after that 2 centimeters of rain falls, we get another centimeter of rain that falls in the next 3 hours. Well, that's just another unit hydrograph, right? Another unit hydrograph, because 1 centimeter of rain. But now the starting point is shifted, right? So now the unit hydrograph is going to sort of look like this. The second unit hydrograph is going to look like this. Now, obviously, my art skills leave a lot to be desired, but the idea is that this second curve, kind of in dark green, is supposed to look exactly like that first curve that is in lighter green. And once again, to show what the resultant hydrograph will look like, what we're going to do, and I guess I'll pick a different color again. Well, maybe we'll pick yellow here. And so the final event hydrograph, which is due to this entire rainfall event, this entire hydrograph, excess precipitation hydrograph given in yellow, will be the sum of the dark green and the red hydrographs. So we'll go, it's going to be the same thing, right? Because there's no addition. Now we start a little bit more, and I'm just kind of trying my best to make this thing sort of like that. So there we go. So this then represents the hydrograph for the precipitation event, the complicated precipitation event that is indicated by the hydrograph in yellow of excess precipitation. So you get the basic idea. So by using the unit hydrograph, we can scale it, we can add it, and we can scale it, and we can shift it to predict the event hydrograph for any kind of input hydrograph, as long as the increments of time here correspond to the increments of the unit hydrograph. In the next video, I'll explain how to create a new unit hydrograph with a different time interval. That's a little trickier.